Stop scrolling. What if I tell you that you can identify whether a huge number is divisible by 2, 3, 5, 7, 11 or even 20 without performing actual division? In today's video, I will teach you all divisibility rules from 1 to 20 that can save precious time in placement exams. Welcome back to day 2 of our 100 days Aptitude challenge. Let's master divisibility tricks that recruiters expect you to know. Let's begin with what is divisibility. A number is said to be divisible by another number if it leaves no remainder after division. So the example is 20 divided by 5, that equals to 4. So there is a remainder 1. So that is the divisibility. Here we have 1 to 20 divisibility rules. Any number is divisible by 1, that's the easiest rule. For 2, check the last digit, like 0, 2, 4, 6, 8, 6, 8, 5. This is not the divisible by 2. Why? Because it ends with 5, not these numbers. The fast trick is just check the last digit. And coming to divisible by 3, add all digits. If the sum is divisible by 3, the number is divisible by 3. That means, for example, 372. We need to add each and every digit. 3 plus 7 plus 2 equals to 12. 12 divisible by 3, obviously. So we need to add. The trick is we need to add each and every digits in the given number for 3 divisibility. And coming to divisible by 4, check the last 2 digits. For example, 13, 16. Here we need to take 16. Last 2 digits are 16. 16 is divisible by 4. That means we need to check last 2 digits for divisible by 4 type of questions. Divisible by 5, we need to check 0 or 5 at the last. For example, 145, it is ends with 5. 780, it is ends with 0. So these are valid. And 123, it is not valid. Why? Because it is ends with a 3. Coming to divisible by 6, must be divisible by 2 and 3. Why? Because 2 3 is 6. So we need to check each and every number with 2 and 3. So 2 3 4 even number. So it will be divisible by 2. And we need to check 3. For 3, as I said, we need to add each and every digit in the given number. So we need to add 2 plus 3 plus 4. So we got 9. Therefore divisible by 6. Why? Because this given number divisible by 2 and also 3. That is why it is also divisible by 6. Coming to divisible by 7. Double the last digit and subtract from the remaining number. That means, for example, 203 is the number given and we need to double the last digit. That means 3 into 2. Next we need to subtract the remaining value with doubled value. So 20 minus 6, 14. If 14 is divisible by 7, then this number also divisible by 7. And coming to divisible by 8, check last 3 digits. For example, 4120. The last 3 digits are 120. So we need to check 120 divisible by 8. It will be easy to check rather than this. And coming to divisible by 9, add all digits like divisible by 3. For example, 7 to 9. We need to add 7 plus 2 plus 9. It will give 18. 18 divisible by 9, it is true. So this number is divisible by 9. Coming to 10. 10 divisible by 10. Last digit must be 0. So the examples are 540. It is valid one. Why? Because it ends with 0. And coming to second example, it is also ends with 0. So it is also valid one. And 11 divisibility. Find difference between alternative digit sums. For example, 1 to 1. Alternative means here 1 and again 1 is the alternative. So we got 1 plus 1. Digit sum, alternative digits sum they mentioned. That is why 1 plus 1. Alternative are 1 plus 1. Again difference between. That means we need to subtract from alternate digits sums. So here one place, first place and third place will be the alternative ones, and second one is the alternative another sum. So 2 minus 2, 0. Therefore this given number 121 is divisible by 11 and divisible by 12. Must be divisible by 3 and 4. Why? Because as I said, for 6 divisibility of 6 we need to check 2 and 3, right? Like that we need to check 3 and 4. For 12 divisibility by 12. For example, we need to check for 3. We need to check, we can able to check 4, 3, 2. We got 9. Last two digits. That means for 4, 32. 32 is divisible by 4. So we got an answer. The given number is divisible by 12 and divisible by 13. Remove the last digit. Multiply it by 4 and add it to remaining number. We need to check this very thoroughly. Why? Because there is something we need to multiply it by 4 and add it to remaining number. So for example, 28. That means remove last digit. We need to remove last digit. Here last digit is 6. We removed and multiply it by 4. Removed last digit value, multiply it by 4. So 6. We removed 6 and we need to multiply it and we got 24. And here they mention add it to remaining number. So 28 is the remaining number, right? We got 24 for this multiplication. So adding both, it will give answer whether the given number is divisible by 13 or not. Why? Because we need to check 52 is the smallest number when compared to 286. So we can able to check whether it is divisible by 13 or not. If that number is divisible by 13, then it is also, the given number is also divisible by 13. And coming to divisibility by 14, must be divisible by 2 and 7. That means 2 to the 7 to the 14. That is why we need to check 2 divisibility and 7 divisibility individually. Then if both divisibilities are okay, then this 14th divisibility of this number also okay. For that we need to check even or not. The last digit is even and also divisible by 7. How we need to check divisibility by 7? Here we got, we need to check last digit into twice and remove that from remaining number. So let's check this. Yeah, 14, right? Yeah, 4 2s are 8. So we got 29 minus 8. 29 minus 8, it will give 21. 21 is divisible by 7. So both are valid. Therefore the given number is divisible by 14. Divisible by 15. It must be divisible by 3 and 5. Why? Because 3 into 5 equal to 15. And this is the number we got, and we need to check whether that number is divisible by 3 and 5. So for 3 we need to add individual digits in the given number, and we got 12. So 3 divisible by 3, 12 is divisible by 3 only, and last digit we need to check 5 to check whether the given number is divisible by 5 or not. So it is also valid one. We got correct answer. And coming to divisibility by 16, check last 4 digits. We need to check last 4 digits. For example, 1008, 63. Therefore divisibility by 16. So I think we need to check these 16 divisibility thoroughly. Why? Because there is no shortcut to it. Divisibility by 17. Multiply last digit by 5. Subtract from remaining number. That means here last digit is 9. 9 into 5, we got 45. Remaining one, 28. So we got minus 17. We won't consider minus values, so let it be. Minus, we need to remove minus. The remaining number is divisible by 17. Then the given number is 17. Divisible by 17. Divisible by 18. Must be divisible by 2 and 9. So the given number is even. The last digit is even. So it is divisible by 2. For 9, we need to add each and every digit in the given number. Then we got 18. So it is also divisible by 9. If both are divisible by both individuals, 2 and 9, then we will able to conclude that it is also divisible by 18. Divisible by 19. Multiply last digit by 2. That means we need to check that 133. Here given number is 133 and last digit is 3. We need to twice that. 3 into 6, 3 into 2, 6. We got 6. For that we need to add to the remaining number. So we got remaining number 13 plus 6. 19 is divisible by 19 and divisible by 20. Last digit must be 0 and last 2 digits divisible by 4. So we need to check last digit is 0. Next, last two digits divisible by 4 or not. We need to check. Last two digits are 40. 40 means it is obviously divisible by 4. So it is also, the given number is also divisible by 20. Most asked interview questions are, I have attached to in that PDF, that are 567 divisible by 3. We need to check. 3 means we need to add things. Then we got 18. So obviously 3 is divisible by 18 is divisible by 3. And coming to question 2, is 7 to 8 divisible by 8? Last 3 digits we need to divide. So we got 91. Whether the given number is divisible by 8 or not, we need to check. Like this I have attached these questions. Kindly go through that. And the revision sheet also I have mentioned. If you want this PDF, comment below.